We're going to briefly look at magnetic data storage as an application of metallic spintronics. So this finds applications in audio tapes, video cassette recorders, computer hard disks, floppy disks, credit cards, etc. So if you look at the history of a hard disk drive, the first hard disk drive was a RAMAC, Random Access Method of Accounting and Control, that was built by IBM in 1956. And this hard disk drive had 2000 bits per inch square areal density, 70 kilobits per second recording rate. It consisted of 50 24-inch diameter disks that hold a total of 5 megabytes of data. It cost about $100,000 and it occupies so much space, it fills a room. Compared to today's hard disk drive, we have more than 100 gigabytes of data storage possibility in a hard disk drive, 400 gigabits per inch square areal density, and price is less than $100. So I would like to talk about a brief history of RAMAC, and I will give you the link to this video so you can watch the full video later.
To design and build the prototype machine took 300,000 working hours. It was named RAMAC, for Random Access Method of Accounting and Control. The first electronic computer able to keep business records up to date and make them instantly available. For the first time, management need only request the current status of any account. The operator types in the inquiry, and RAMAC types out the answer. Each RAMAC record file contains 5 million characters of information. This file unit may be connected to other computers to provide even larger warehouses for facts. To engineer RAMAC for assembly line production meant rechecking every specification. From the day testing began, we in production made 1,400 improvements, ranging from moving a control button to a more convenient location to simplify, make them available.
Let's take a brief look at also the modern hard disk drive, how a modern hard disk drive works, and I will also give you the link to this video.
I'm Joanne Larson. I work at Seagate in a design center. I have two drives here just to illustrate a couple of form factors that we design. This is an example of a 2.5-inch drive, as we call it, which would be used, for example, in a notebook computer. This is what we call a 3.5-inch form factor. A hard disk drive is so named because the heart of the matter is where the data is stored, which is on these disks, and the data is stored magnetically as ones and zeros, or as magnetic bits that are oriented north or south. It is read or written, as we say, by very small transducers on heads. So this little roughly triangular shaped feature can be thought of as the size of a bit. When we write, and this is the write pole, the flux is essentially focused through that pole. The corresponding area on the media below it is magnetized. The head is out flying on a suspension at the end of an arm. This is an arm, which is part of what we call the head stack assembly. The arms move back and forth across the stroke and read the various tracks that are laid out on the disk. These tracks are so narrow that we fit about 300,000 of them in an inch of radius. The arms, the HSA pivot, is actuated, in this case, and I think this is kind of fun, magnetically. As we know, electricity and magnetism exist together, and when a current is run through a wire, there is a corresponding orthogonal magnetic field. So how we are using that here is that there is a coil, which is, it's actually hidden under this magnet. Under this plate there's a magnet. And below the magnet is a coil. The driving force of the current, or conversely the magnetism, forces the back end of the coil to move in one direction or the other. Right here we see the motor that spins the media.
Okay, so you can watch the full video later on. Basically, the main components of a hard disk drive are the storage medium, the write head, and the read head. And for the storage medium, we have the actual tape or disk, the magnetic medium where the data is stored. The write head, as you have seen in the video, is a wire coil wound around a magnetic material that generates a magnetic field, just like an electromagnet. The read head senses the magnetic orientation in the recorded regions. Now, in order to build an ideal hard disk drive, one would require high coercivity medium so that we have the thermal stability of the bits. The information that is written is not lost in time. We need low head disk spacing to have improved areal density so that we can pack a lot of information in a very small area. We need high sensitivity read heads to sense field lines coming from smaller and smaller bits. And finally, we need a high magnetization write head in order to generate high fields, the fields that are enough to switch the orientation of the bits in the magnetic medium.